Okay, our essential question this time is how does the value of c affect the graph of f of x equals ax squared plus c? Now, let's do a little bit of a review real quick. So before this, in the previous lesson, we talked about this idea of a parent function, which was basically f of x equals x squared. And we said that we're going to make changes to this parent function. And last lesson, we looked at these changes when there was a number in front of the x squared. And we saw how that number made vertical shrinkages or vertical stretches towards that vertical line. So if you look closely at the one we're currently looking at, it's almost the same. It's the ax squared, but now they've added a plus c. So we're not just going to have a number in front here, which is the a. We're going to be adding a plus c at the end. And so how will that now affect it? In other words, we're not doing this, just this, I should say. We're going to do what we were doing before, but we're going to add a c to it. Just to remind you, though, that's still not standard form all the way. I mean, it is, but quadratic standard form, if it had every possible component it would also have a b in there. Notice that we're doing the ax squared the first time. Now today we're doing the ax squared plus the c. So yes, you've guessed it, in the future lesson we'll learn how to handle it when there's a b in there, or bx, okay? There's a number in there. But this is really an easier way to teach it, is to start off with this. So how does this c influence the parent function? Dun, dun, dun. Okay, if you want to follow along in the textbooks, you can. It's on page 426. This is a little hard to read. I do my best, but it's a little hard to read. But I just took it from there. And again, it's just that new thing we're learning how to graph when you have a c at the end. Well, there's two different ways you can do it. It depends on if the c is greater than 0. Another way to say that is if it's a number, like a 1 or a 2 or a 3. It's just any number greater than 0. You're going to do it like this black underline. It's going to move up. This is really a simple idea, but if you look here on these parabolas here, these curved graphs, the black lines just moved up. So if it's a positive number, it moves up. What if it's less than, if c is less than 0? Well, if c is less than 0, it's going to be a negative number, right? Any number less than 0. So we're going to move it down that many units. These have an absolute values, because we're talking distance, right? How many are you moving it down? So we're not moving it down a -3, but we're moving it down 3. But yes, it's because it's negative. Okay. The other interesting thing about this is that the vertex of the graph. Remember, the vertex is the minimal point or the maximum point if the U-shaped parabola is going this way. In this case, they're all minimum points. The minimum point is going to be 0 for the x, right? But then the c, whatever the c is, will be the y. Whatever this number is, it's like the y-intercept, right? It will be the vertex. And the axis of symmetry is still 0 because we're only moving the chart up if it's positive and down if it's negative. And that moving up and down is called a translation, a vertical translation. But we'll get more into that. I'm get ahead of myself. Okay, I know I cover a lot in that first few minutes of this, so a lot of this is theory at first, but we're not actually seeing any work. We're just reviewing these ideas. So let's get to some practice of how this actually works. So it says graph g of x equals x squared minus 2 and compare it with the graph of f of x equals x2. Another way to say that is graph this and compare it with the parent function. As you can see, that is the same thing as the parent function. Remember, everything is being compared to the parent function. So what are the steps? Well, the good news is, I'll give you a hint here. Yes, the good news is that the steps are the same. as they were when there wasn't a -2. The first step is to make a table. See, I made a table. The second step is to plot. The third step is to draw a curve through the point. So it's basically the same steps we've been working on. So the first step is to make a table. Now, I've asked you already to write the parent function down, so you all should have that already. And I asked you to write it on a flashcard. You should have that already. And if not, they should be in your notes for 8.1. So now I'm just going to focus on not the one that we use every time, but the new one. Okay, so we're going to have the input and the output. So if we input an x, what will be the output? What will be the g of x? Okay, so we can try lots of numbers. I don't know. Why don't we just choose the same numbers we chose for our parent function? So I'm going to scoot the parent function over right here. I think it's still in sight, but we don't really use it. And let's figure out this one. So if we were to substitute in these numbers for the x value, what would we have? Let's start with the first one. G of x equals x squared minus 2. I just rewrote the new parabola. But instead of an x, when I rewrite it, I'm going to substitute in the first value we chose, which is a -1. So g of -1 equals -1 in place of the x squared minus 2. But a -1 squared, what is a -1 squared? Well, -1 times a -1 is a +1. So we would have a 1, this +1, but we bring down the -2. And what is 1 minus 2? It's a -1. So if we indeed input a -1, our output would also be a -1. Good. Okay, 0 is the easiest of all to do. In fact, we're going to do it in our heads just because it's that easy. If we input a 0, so we're going to square 0. Well, 0 times 0 happens to be 0. Then we subtract 2, we just have a -2. What do you think we'll have if we input a 1? Well, won't it be the same as a -1? Because when we did a -1, we squared it. We did a -1 times a -1. But a negative times a negative is just a positive, or it's a weird happy face if you want to draw a circle around it. But it's it's a negative times a negative is just a positive, right? So if a -1 times a -1 is a +1, well, that's the same thing as a 1 times 1. That would also be a +1. So you're going to get the same answer. Okay, so what's 2 going to be? Well, let's do it in our heads. 2 squared, 2 times 2 is 4. 4 take away 2 is 2. Okay, so I went ahead and I graphed the parent function already. It's in pink. It stands out because it's in pink. At least that was the intention. So this is already done. In fact, I went a little beyond. I went to 3 and 9. But this is what a parent function looks like. So we want to compare it with this right here, this new question that it's given us. So let's substitute it in and see what we get. If x is a -1, what would the g of x be? You could ask if x is -1, what's the y? I mean, that would also work. If x is -1, well, g of x is -1 as well. So -1 for the x and -1 for the y. If x is 0, y is -2. If x is 1, y is a -1. So if x is 1, y is a -1. If x is 2, y is 2. Okay, let me go on this side. If x is 2, 2. Okay, what the heck? Let's just do a 3 real quick. It's not hard to do. 3 squared, 3 times 3 is 9. 9 take away 2 would be 7. So if it's 3, 1, 2, 3 for the x. 1, 2, 3, 4, 5, 6, 7. Okay, so if it's 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, now we can really compare these parabolas here. So just based on a visual inspection, what are you observing about these parabolas? What do you notice about them? Well, the first thing I want you to observe is that we basically just went down 2. I had a paper clip I was going to use. Here it is. But basically, we took this whole parabola. Thank you, paperclip. And we went down 2. If you keep your eye on the origin here, see that? I just move it down. See how it's on top of the pink? And you just go down 1, 2, and it's on top of the black. In other words, it didn't really stretch, or it didn't really shrink. All you did was move it down 2. It may look like it's kind of an optical illusion. It looks like it's stretching towards that y-axis or shrinking away, but it's not. Okay, so all you did was move it down 2, and that's very convenient because why did you move it down 2? Because it says -2. But the question it asks us to do is to compare the graph to our parent function. So we need to make a comparison. And what areas do we want to compare? We have so many choices. The first thing I would say, though, is that they both are opening up, right? Both parabolas here are opening up. So the first thing I would compare is that. Are they reflection of each other, or are they going the same way? Both open upwards. What other observations can we make about these parabolas? Well, they have the same axis of symmetry. If you look at them, the middle line down the middle is the same. Because we didn't move it left or right, we only moved it vertically up or down. So the axis of symmetry still divides them in the middle. So we would say the axis of symmetry is the same. So what else can we compare? We can compare the vertex. What do you think? Is the vertex going to be the same, or will it be different? Well, the vertex for the parent function is 0, 0. I probably should write it in pink just to stay consistent with the pink line. So it's 0 and 0. That's the parent function's vertex, but look at this vertex. It's a little different, right? Because if you look at the minimum point on this one, it's not the same. Yeah, the 0 is the same, the x is the same. It didn't move left or right, but it went down 2. So the vertex actually we find is the same as the question. It's a -2, and the vertex is a -2. -2, -2, -2. The vertex is the same. Good. I'm trying to think if there's anything else we can compare about this. Well, we would want to describe which way the graph moved, right? So this is, I would say, is a vertical translation. That's what we call it when we move it up or down the parabola, the curved graph here. And it's a vertical translation. We went down 1, 2. So it's a vertical translation 2 units down. So vertical translation 2 units down. And actually, if you look at it, you would say 2 units down of what? Well, even though it's the parent function, they're calling it f of x, so I'll say 2 units down of f. So I'm describing the f of x. Okay, wow. That was a lot of work just to move something 2 times, right? We had to do all this graphing and plotting, and all we really needed to do was take it and move it twice down. So, interesting. Okay, so let's do another one. It says graph the function, compare the graph to, again, it's that same parent function that we've been doing the whole time. I just want to do this first one. So again, what are the steps? What should we do first? And I want to do it because there's a negative, by the way. Yeah, we make a table. We plot it, and we draw a curve through the points smoothly. So the first thing we're going to do is make a table, right? And sometimes there is strategies to the numbers you can put in these on the tables. Since it's not coming up right now, a strategic reason, I'm just going to do, I'll just do like a, I don't know, -2, -1, 0, 1, and 2. Okay, so if you substitute in a -2, what would you have here? A -2 times a -2 would be a +4. 4 minus 5 would be a -1. Okay. Let me work one out just in case someone needs to see it still. So g of what equals what squared minus 5. I just said what instead of writing the x. Since everywhere there was an x, I'm now going to put this next number, a -1. So if you input a -1, well, -1 squared, you know, a -1 times a -1 is a +1. So you'd have a 1, then you would subtract 5. So 1 minus 5 is just -4. If you input a -1, your output is a -4. What if you input a 0? What would you get? Well, 0 times 0 is 0, and 0 take away 5 is a -5. What if you input a 1? Well, 1 times 1 is 1, 1 take away 5 is -4. It should look familiar. It should be symmetric, right? So this should be a -1. And sure enough, it is. 2 times 2 squared is 4. 4 take away 5 is a -1. So we have what we're going to use. Let's go ahead and graph it now. And I took the liberty to already graph a parent function, so now we just need to compare this one with it. And I think I'll stop at this point because I know the video is probably getting long, so let's just graph this one. If x is a -2, the g of x, or if you want to think of it as a y, is a -1. If x is a -2, it's a -1. If x is a -1, the g of x is -4. 4. If it's a 0, it's a -5. And then we just keep going with it. Okay, so let's go ahead and graph this and see how we do. Smoothly connect the dots. And if I want to go higher, just so I can know where that other dot would be, let me just do it. 3 squared would be 9. 9 take away 5 would be 4. So if I was at 3, 1, 2, 3, I'd be at 4. 1, 2, 3, 4. See, I'd be a little steeper like this. Okay, so we're supposed to compare these two. How would we compare them? What are the things that we are looking for, right? Let's see how you do. So it's a vertical translation of the graph, first of all. How many units down? Right? That's the main thing. If I run out of time on this video, I want you to know it's a vertical translation. I think we have time to do it all. Let's just do it. So they both open upwards. Axis of symmetry is the same. The vertex is different for the new graph because it has the same x value, but the y value is now, well, we should be able to know, right, by the question. If it starts off with a -5, then that's your y value. Okay, so the last thing we want to know is the translation. It's a vertical because it went up and down, not sideways. So it's a vertical translation. Five units down. In other words, if I were to take my paper clip and it was at the parent function, I moved it down. If you look at the 0, 0 value, you can just count 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And so basically, we moved it down 5 times because, and we could have solved that. Whoops, let's straighten it out. We could have solved that because the question said -5. We knew we were taking the parent function and moving it down 5. So just like in y equals mx plus b, the b is the y-intercept. This similarly tells you which way you're moving the graph. You can just look at that and be able to tell. Okay, so next time we'll look at what happens when the A has a number. Remember, that was either a vertical stretch or shrinkage, with this idea of translating vertical translations. So we'll look at that next class. Hopefully this wasn't too long, but I thought it came out pretty good, if I do say so myself.